measure of the location of the data, measure the center of the data, and the box plot. Measure of the location of the data. The measure of location, also known as the measure of central tendency, provides information about the center of or the average of the data set. The most three common measures of location are the mean, median, and the mode. The mean is the average of the data set. The median is the number in the middle of the value of the data set when it is ordered from smallest to largest. If there is an even number of value, then the median is the average of the two middle values. For example, if you look at the data set 10, 5, 20, 30, this means here you have the so here 1, 2, 3, 4, 5. So here we have 5 data set, 5 data value. So the one in the median would be 5 minus 1. So to calculate the median here of this data set, the location of the median, you have 1, 2, 3, 4, 5 value. So the location is equal to the number of data value plus 1 divided by 2. So it's 3. So this 20 is the median. Whereas here you have an even number in the data value. So the location, again, it is n plus 1 divided by 2. We have 4 plus 1 divided by 2. This is equal to 2.5. This means the median is the average of the data value at the second and third location. So then that will be 15 plus 20 divided by 2. So the median is 17.5. The mode is the value that occurs the most frequently in a data set. A data set can have no mode, one mode, or even more than one mode. So if the number repeat the same amount of time, they are another mode. So for example, in the first set of data, 10, 15, 20, 20, 25, 30, 20 occurs twice. So the mode here is 20. In the other data set, it said 10, 15, 20, 20, 25, 25, 30. Note that 20 and 25 both repeat twice. So then the mode are 20 and 25. The measure provides different perspective on the central tendency of the data set. The mean is sensitive to extreme value, while the median is less affected by the outlier. The mode is useful for identifying the most common value in the data set depending on the distribution of the data set and the specific characteristic of interest. Different measures of location may be more appropriate to use. Okay. Now let's backtrack a little bit. We said here this measure provides different perspective on the central tendency of a data set. The mean is sensitive to the extreme value, while the median is less affected by the outlier. So let's talk about that for a little bit. Okay. So let's say, for example, ten teenagers reported their earning over spring break. Report their earning on a part-time job during spring break. Nine of them work as pet sitter and receive $15 per hour. One student worked as a hand model and received $300 per hour. Let's calculate the average salary or the average income of 10 students. So you have 10 students, 9 of them earn $15 per hour, and you have one of them earn $300 per hour. Divide by 10 students in total, so 45 plus 300 by 10, this is 345, 34.5. So here, by this calculation, we can see that the average earning is 34.5. However, this number does not really represent the true average of the earning that this 10 student does. Now, note that this one person who makes 300 per hour is the outlier. For the rest of them, they make 15 per hour, right? So you can see here the outlier greatly affect the average. Now, whereas if we just talk about, okay, so what happened if we just look at this in the case of what is the median income? So you have 9 students that earn 15, one student that earn 300. So n equal 10. So if you just lay out this number in a list and calculate the location for the median, the location equal 10 plus 1 divided by 2. This is 11.5 divided by 2. This is 5.5. So that 9 students that make 15 per hour. So if you lay this number out, the first 9 number of 15. So at the location 5 and 6, they are 15 and 15. So this telling us that the median is 15. So this is more better representation of the earning that this 10 students received during the spring break. Okay. Well, let's go back to what we was talking about. Now, there are different measurements. Say we have quartile. Quartile divide the data set into 4 equal parts, each representing 25% of the data. The three quartile are commonly known as quartile 1, quartile 2, and quartile 3. First quartile, the value below which is 25% of the data fall. It means it is the median of the lower half of the data set. The second quartile, quartile 2, the value below with 50% of data fall. It is the median of the entire data set. Third quartile is the value below with 75% of the data fall. It is the median of the upper half of the data set. Now to calculate a percentile, the percentile divide data set into 100 equal parts. it representing 1% of the data. Pth percentile is the value below with p% of the data for. The percentile equals p divided by 100 multiplied with the number of data point plus 1. We work more on that in a little bit. Now, the interquartile range is the number that indicates the spread of the middle half of the 50% of the data. It is different between the third quartile and the first quartile. So what does it mean? The interquartile range will measure the spread when we use the interquartile range to calculate the potential outlier value. If the IQR interquartile range, so the interquartile range can help determine the potential outlier. A value is suspected to be the potential outlier if it is less than 1.5 IQR below the first quartile or more than 1.5 IQR above the third quartile. The potential outlier always requires further investigation. Yeah. So let's take a look at a couple of examples. We want to calculate the mean and the median for the data set. The mean, this is the average of the data set. So first the mean. Or we call this X bar. I will add all the X value, divide by the number of data set. And to do that, I will use the aid of the calculator. I'll go to Stat. I will enter this value that I have into list 1. Since it is a small amount of number, you can find this by hand, but it's not really substantial if you have a larger set of data. So I will just show you how to use this on the calculator with a small set of data. So we put in the list of our number. Then we go to Stat and calculate one variable statistics, one variable stat, and our data in list 1. So it's telling us here that the mean is 29.375. So this route to 29.4. The median so how many value do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the location equal n plus 1 divided by 2. So 9 plus 1 divided by 2. This equal 5. So the median is the 5th number in this list. So 1, 2, 3, 4, 5. So the median is 30. Well, in the previous problem, we calculate the average for the single data point value. You have the list of number and then you calculate it by the mean by add up all the value divided by n. So what happens if we are given a table distribution that show right here? Well, between 0 to 3.5, we can't really use this in a calculation. Well, we don't know how, right? So what we need to do in this case, if we are given a table distribution with each group like this, the first thing you need to do first is to calculate the midpoint. The midpoint is the average of the lower class limit with the upper class limit. Okay, so let's start finding the midpoint. So first of all, we got for each number, so it will be 0 plus 3.5 divided by 2. So we get 1.75. The next one, 3.5 plus 7.5 divide 2, 5.5. I then will enter this into my list. Average is equal to the total of the midpoint multiplied with the frequency divided by n. Okay. So in our next column here, we have to find the product of xm times the frequency. I can do that on our calculator. Go stat. Earlier in list 1, we already have midpoint. In list 2, we can enter in our frequency. And in list 3, we can tell list 3 that we want this equal to the product of list 1 and list 2. Okay. So here we get our list 3. So now we can tell the calculator to calculate the sum of list 3. And go stat, count, list 3. So we're told the sum here is 373.75. The next thing we need to find n. N is the total number of teenagers participate in this survey, right? So then I can find that is the sum of list 2. That is 9.84 hours. So this telling us that on average, teenagers spend 9.84 hours on video game. Let's calculate the mode. Well, you're looking at this table, the frequency that repeated most is 12. So this meant that on average, students spend about 7.5 to 11.5 hours on video game.